we talked about how today is a review of Unit 2, which is all things right triangle, and then Unit 4, which is extending the number line. So Unit 2, we started off with Pythagorean theorem, which we can use on any right triangle, and now we're going to talk about the special right triangles. So our special right triangles are the 30, 60, 90, and the 45, 45, 90. Now, on the XAT, they actually give you that the short leg is x, that the long leg is x root 3, and that the hypotenuse is 2x. That is on the formula sheet for the SAT. It is not on the formula sheet for your end of course test though. So the trig ratios are, but the ratios for our special right triangles are not. So on this one, it's the short leg is x. We always double that to get the hypotenuse, and we multiply that by the square root of 3 to get the longer leg. On the 45, 45, 90, whatever one leg is, the other has to be the same because they're congruent. And then to get the hypotenuse, it is times the square root of 2. Now, sometimes when we're memorizing stuff instead of understanding stuff, things get mixed up in our brains. So if you memorize this when we did it instead of learned it for understanding, you may get confused about where the square root of 3 goes and where the square root of 2 goes. Here's a quick way to remember. A 30, 60, 90 has 3 different angle measures. It has 3 different side measures, and it has a square root of 3. The 45, 45, 90 has 2 different angle measures, 2 different side measures, and a square root of 2. All right? So if you memorize that instead of learned it for understanding, you might get confused about which one has a square root of 3 and which one has a square root of 2. So one more time. Square root of 3 has 3 different angle measures, 3 different side measures, and a square root of 3. 45, 45, 90 has 2 different angle measures, 2 different side lengths, and a square root of 2. So let's just do a quickie. What would this look like? I'm just going to remind us first, and then I'll tell you what I think it's going to look like. And there was the answer to the problem I did first period. I'll change it up for this period since I showed it to you. All right, let's say I told you that this was your 30-degree angle and this is 10. What are the lengths of the other 2 sides? What is the short leg? 5. 5 root 3. Okay? Now, let's say they started with something different. Okay, let's say they told us that this was 9. What would we do to find the short leg if they give us the long leg? Divide by the square root of 3. Can we leave a radical in the denominator? No. So we would rationalize. So we'd get 9 root 3 over 3, which simplifies to 3 roots of 3. Now, some of you like to think backwards like I do, and I would have just said in my head, okay, what number did I multiply by the square root of 3 and get 9? And that's all my brain needs. And I go, oh, that's 3 roots of 3, because root 3 times root 3 is 3, and 3 times 3 is 9. But this always works. Okay? And then we would double this short leg to get the hypotenuse, so it would be 6 roots of 3. Are we good?
Yeah.
Okay. Now let's take a look at 45, 45, 90. Okay? If we knew that this was 6, what would this side be? 6. And what would this be? 6 root 2. Okay. Now let's start with the hypotenuse. Let's say this was 12. What would we do to get the other 2 sides? Divide by root 2. Yep. So we get 6 roots of 2. Or you could do the same thing. Ask yourself, okay, what did I multiply by root 2 to get 12? So, on your end of course test, I imagine, never seen your end of course test, but I imagine that it'll be in some form of word problem, or it'll be a problem contained in another picture. Like there'll be a 30, 60, 90 inside of something else, or 45, 45, 90 inside of something else. Or we'll start with the area of a square is 36 square inches, and then they'll cut out an equilateral triangle and say, what's the area of the shaded region? So I don't think it'll be completely straightforward like this. I think it'll be probably something that's slightly more complicated. So we know if this is equilateral and the area of the square is 6, this side is 6 and this side is 6. And if we drop down a perpendicular and we knew this was an equilateral, that's a 60-degree angle. So right here's my 30-degree angle, right? So if all the way across was 6, what is halfway? 3. So the short leg is 3. So what the altitude of that triangle be? 3 roots of 3. So I could do the area of the triangle, the area of the square minus the area of the triangle would leave me the shaded region. And so area of a triangle is half the base of the triangle, which is 6, times the height of the triangle, which is 3 roots of 3. So it would be 36 minus 9 roots of 3 square inches. So I think if you have something, it'll be something contained in something else. Or my favorite kind, which probably means it won't be on the end of course test, would be if they gave you like a 30, 60, 90, world's worst drawing of a 30, 60, 90, with say a 45, 45, 90 inside of it. Okay? So, all right, and they might give us this is 20, and what is this? Or they might give us this is 20, and what is this? Okay, so if this is 20, and that is on the 30, 60, 90, the big one, that's the hypotenuse, so what would the short leg be? 10. What would the hypotenuse be then of the 45, 45, 90? 10 roots of 2. Okay, well, if the short leg is 10, then the long leg would be what? 10 root 3. Well, how do I get this y part?
10 minus 10.
Yeah, because if this leg of the 45, 40 is 90, isn't this leg the same? So it would have to be 10. So y would be 10 root 3 minus 10. Okay, so I could be dead wrong on this, but I really think they'll give you something that's either word problem, and you have to draw it, or where it's one of these mixed inside of another problem. Okay?
Let you know.
Yeah. Oh, well, you can't tell me with the exact problem because you can give me a vague about. Or you can say, Miss Wilby, you were dead wrong. It was straightforward. And in that case, we'll all rejoice because we got it right and we'll move on. Oh, wrong button. Okay, so that's really all there is to special rights. Now, then we talked about right triangle trig. And there are 6 trig ratios, sine, cosine, tangent, secant, cosecant, and cotangent, but you were only responsible for 3, not the reciprocal functions. You should have learned sine, cosine, and tangent. And the mnemonic that we used was SOHCAHTOA. Sine is the ratio of opposite over hypotenuse. Cosine is the ratio of adjacent to hypotenuse. And tangent is the ratio of the opposite side to the adjacent side. Of all the things they chose to put on your formula sheet, they chose this. You guys all memorize SOHCAHTOA. This is something we're not going to forget. But if we do, we can find these trig ratios on our formula sheet. Okay, so as you're piling up your list of things I need to make sure I know, this one's on the formula sheet. So you might be just fine. All right. If they ask us for sine of an angle or cosine of an angle or tangent of an angle, all they want is the ratio. Now, that ratio, they may give us in fractional form, or it may be in decimal form. So let's say this side is 8, and this side is 10. What would we do to find the missing side? Pythagorean theorem. But this is one of our multiples of 3, 4, 5, isn't it? So the Pythagorean triples we talked about knowing were 3, 4, 5, and 5, 12, 13, or multiples of those. And Brian immediately got excited because he was like, ooh, that's a multiple of that 3, 4, 5. It's twice that, so this side would have to be 6. Now, if that didn't come to you quickly, then you immediately go into Pythagorean theorem mode, and you get there fast. 100 minus 64 is 36. Square root of 36 is 6. Done. Okay, so if it asks us for sine of theta, well, I marked theta here. They might say sine of angle A. They might call it A. Okay, so sine of theta is just the ratio. With respect to theta, this is the opposite side, this is the hypotenuse, this is the adjacent. So sine would be the ratio of opposite to hypotenuse, 6/10, which reduces to 3/5, which is the same as 0.6. You will see one of those answer choices, either 3/5 or 0.6.
Wait, so Miss Willoughby,
Yes.
so if it's just like, if it just says like sine, it's not asking for like, it just wants a ratio?
Right, if it says sine of theta.
Okay.
Now, if it asks you what is the measure of the angle, then you got to go one step further, and we'll do that in just a minute.
Don't you like do the inverse?
Yes, you do. Good, good. All right, what is the ratio of cosine of theta? What represents cosine of theta?
You didn't even know how
Ka.
to do this.
So adjacent over hypotenuse. 8/10, which reduces to 4/5, or we could write it as 0.8. So your answer will be in either of these forms. Tangent. Tangent is the ratio of the opposite side to the adjacent side. The opposite side is 6. The adjacent side is 8. So these will be your answer choices. 3/4 or 0.75. So if it just asks for this, do not give it the angle. It'll ask for theta if it wants the angle. This would just be the ratio. Any questions? Okay. Now, I think the rest of this will be in word problem form, which is great because that's what we spent most of our time doing. We did problem after problem after problem. Do you remember? So-and-so is standing on a cliff and the angle of elevation up to the guy is this and the sun is at, we did lots and lots and lots of these problems.
Wait, Miss Willoughby, real
Yes.
quick. When it's got like, because I know like the sun thing and it's like angle of elevation, what is it talking about?
Well, I'll go over that
Which
again.
angle
That's
is
fine.
it?
That's fine. I'll talk about that again. Oops, I forgot one thing though. All right, here is a triangle ABC, and I've given you the sides. This is a 3, 4, 5. Do you see, what would the ratio for sine of A be, guys? What is the ratio for sine of A? 4/5. What is the ratio of cosine of B? 4/5. They're the same, aren't they? Because the sine of an angle is always the same as the cosine of its complement. So sine of 70 is the same as cosine of 20. Cosine of 50 is the same as sine of 40. Because sine of any angle is the same as cosine of its complement, and vice versa. Cosine of any angle is the same as sine of its complement, of any acute angle. All right, did you remember this concept? Or does that refresh you, and at least now you're like, I think I may have heard that at some point in my life. Okay, now let's talk about how we would see these types of problems, and let me add in a page here, and we will talk about angle of elevation versus angle of depression. Okay, so Drew is out on a nice, pretty April. Whoops, he's doing a split. He's doing a split, and he's out flying a kite. It's a nice, pretty, windy day. All right. So what we have here is we would have from here to here, the angle going up, this is an angle of elevation. So I'm sure during spring break, when Drew went to the beach, he flew a kite.
I didn't go to the beach.
Well, let's dream you did. Okay, and then after flying the kite, he spotted a lighthouse.
What?
Yeah, he did. Okay, we'll call it a lighthouse. Looks like a barbershop. Okay, hush. And he climbs to the top of the lighthouse, and he spots way out here in the ocean a sailboat.
These are actually spot on like examples of what
Okay.
you usually see.
So here he is. He's looking down at the sailboat. I missed the sailboat. But this is an angle of depression. And the great thing about angle of elevation and angle of depression is when we draw in the triangles that we can draw in, we see that they end up being the same. Like the angle of depression going down to the sailboat would be the same as the angle of elevation going up. Because with these horizontals, they're like parallel lines. So the angle of depression, which happens to be outside my triangle I drew, is the same as the angle of elevation going up.
Interior angles are congruent.
Very good. Alternate interior angles are congruent. Awesome. All right, so does that help us remember angle of elevation and angle of depression? All right. Who's a Boy Scout? Not a single person in this room. Okay.
I actually dropped out of
you
Scouts.
you were? Okay.
A year ago.
Let's pretend, since we're talking about Drew today, let's pretend that Drew didn't drop out of Boy Scouts and he's working on his Eagle Scout badge and he has to do a project, and so he notices that over at his neighbor's house the lady fell and now she's in a wheelchair for a couple weeks and she needs to be able to get in her front door. So Drew, being the nice count Boy Scout he is going to build her a ramp. And so he knows that the angle of elevation of this ramp cannot exceed 15 degrees because that would be a safety hazard.
You don't want her speeding
Right.
down that ramp.
And that's right. We don't want her going too fast. And the height of the porch off the ground is 3 feet. So how long? When he goes to Home Depot, he doesn't want to spend more money than he needs to. So he wants to know what type of 4x6s should he buy? How long do they need to be in order to build this ramp? So what we would do is we would kind of set it up, draw a picture, we'd look at it. Okay, we want to know how long, what kind of wood we need to make the ramp. We want to know this. So this is going to be the ratio of the opposite to the hypotenuse, which is sine. And so we do 3 divided by x. And so to solve it, we'd multiply by x. And then we divide by sine of 15. So what is 3 divided by sine of 15? And before you take your end of course test, every single person in here is going to hit the mode button on their calculator and make sure it says degrees. Yeah, and you're using these kind, not graphing ones, because we're practicing with these, because that's all we get to use.
Fantastic investment.
It is.
Welcome to Home Depot. How can I help you? Yeah, I need a blank of wood that's exactly 3 over sine 15.
Okay, see, that is the problem. If you went to Home Depot and asked for a length of wood that was 3 over sine of 15, whoever's assisting you may not know how to do that. So it's best that you do that conversion before you end up at Home Depot.
Divided by
11.59.
Okay.
That's a really long ramp.
So we know that the ramp's going to end up being about 11.59 feet. So he's probably going to buy 12-foot boards. So if we had choices like A was 10, B 10 feet, B was 11 feet, C was 12 feet, D and 13 feet. What would we buy to have the least amount of waste, to spend the least amount of money? It would be C. Okay. So, word problem may not look anything like that, but it's going to be a word problem. You're going to sketch a triangle. You're going to stick the stuff in it you need. Figure out which trig ratio represents your triangle. Set it up and solve. Okay? So, all right. So, Drew's out flying the kite.
You enjoy your kite.
He does. Kites are fun. Kites are fun.
I've been flying a kite since I was in the first grade.
You remember last time?
All right. So here he is flying the kite, and I didn't put it in the right space because this is my. Here, I'll move the triangle. All right. So here he is flying the kite again, and this is the string for his kite. Ooh, I need to put him closer to the kite.
It's really alright.
He's got mic control.
All right. So what we want to figure out this time, is the angle of elevation, which is probably not what we'd really want to figure out. So he's got his friend Connor standing over here, and he measures this distance. He's directly under the kite, and I say, okay, that's 30 feet.
This is what you do.
Okay?
Let's do some math.
All right?
Kite distance.
And they had marked the string, so they marked it every foot, so they knew that they released 50 feet of string.
Two things to remember when you're flying a kite.
Okay? So what is this angle of elevation? So we have to figure out what is our trig ratio that we're dealing with here. Which one is it? Sine, cosine, tangent? Cosine. This one's cosine. So cosine of that angle is equal to 30, which is the adjacent side, over 50, which is the hypotenuse. So 3/5. Oops, marked out the 5, didn't mean to. All right. Whenever we're solving for the angle, we have to use the inverse. So what we would do is inverse cosine of 3/5. And what would that angle measure be? Okay, on these calculators, you have to push the button twice. Cosine, cosine gives me inverse cosine. And you get that angle of elevation is approximately 53 degrees.
0.13.
No.
Okay.
Well,
So we might have something like that. We might have something like you're laying out on the beach during spring break, getting a tan. Okay? And the sun's over here, and what is the angle of elevation to the sun? If you got some kind of shadow from the tree that is just missing you. And the shadow, yeah. So that's a tree. What is wrong? Hold on.
There we go. Wait, at the beach?
I don't think
No,
they're
let
making shit all
them
over.
be.
Oh, palm tree, palm tree.
as to this scenario,
Whatever.
World's best palm tree, I might add.
Good.
Coconuts.
There's no coconuts yet.
On a palm tree? You're right. You'd have to have a coconut
You need
tree.
the like little spiky thing right under the things.
Okay, this is as best I can do. Okay?
Palm trees have coconuts.
Palm trees have coconuts.
About this.
All right, Unit 4. Luckily, the drawing is over.
Oh, no.
All right, Unit 4 was our extending the number line. So we did complex numbers, we did radicals and rationals, rational exponents. So complex numbers in this a plus bi form, where a is our real number part and b is our imaginary part. Because remember, we defined the square root of -1 as I, which is the imaginary unit, right? And we did that so that we can solve any problem where we have to take a square root of a negative. Otherwise, we're stuck. We can't go any further. Now, we also did a little experiment and figured out what our powers of I were. I squared is -1. I cubed is -I the fourth is 1. Okay, your calculator is limited in what it will do, but if you had a complete brain freeze. Your calculator can do some of this. If you hit the mode button on your calculator, do you see that the fourth thing down says real, and then the one next to it says A plus BI? So it can do some of this, and do you see that I is on the same button as pi and E?
Yes, I do.
So it can do some of this. It's just very limited, and sometimes the answer is not in the right form. Like if you type in 3 times the square root of negative 20, it's not going to give us the right form. It'll give us the decimal approximation instead of the exact radical.
Mine didn't even give me that. It just said domain error.
Did you put it in A plus BI form? You have to put it in A.
Like I squared, though, it'll give you like what it
Yeah,
is.
if you do I squared, it'll tell you negative 1. Yeah. Okay, so let's talk about how to simplify a radical. 3 root negative 20 we would think of as negative 1 times 4 times 5. The square root of negative 1 is I. The square root of 4 is 2. And the square root of 5 is irrational. So it stays under. So this is 6I root 5. Do we remember simplifying those? Great. We also added complex numbers. We subtracted complex numbers. We raised complex numbers to powers. And remember, we were looking at, we would divide by 4 and go, oh, that's the same thing as I cubed, and I cubed is negative I. Will your calculator do I to the?
It won't do high numbers.
No, it won't do high numbers. So you would have to know, you would have to remember that. Good.
Wait,
Woo!
why
Makes
do
you
I
remember
vote
something.
'Cause
You look at the remainder when you divide by 4. So 40 divided by 4 goes evenly 10 times. The remainder is 3. So it's the same as I to the third. And I to the third is negative I. Okay?
So just divide it by a high number, or does that have to be 4?
Always 4 because the pattern repeats every 4. So because the pattern repeats after the fourth one, that's why you divide by 4. Okay,
What is it when you get it out for the first one? Like, because there's like I to the first, I to the second, I to the third, I to the fourth. Like, what if you get it out for the first one? Like,
They make you cover it.
I to the first is just I.
That's
Okay.
what it is.
Yeah.
What if you got like a tattoo of like the formulas? Would you be allowed to like take like cover it with duct tape?
That would be something that I would have to report, and then I don't know what they do.
Get it removed.
They'll probably ask you why.
You know what? Crazier things have happened. So
Like
it wouldn't surprise me if one day somebody did come in with a tattoo of mathematical stuff. All right. So here we have a complex number, 2 minus 3i. What would its conjugate be?
2 plus 3i.
2 plus 3i. We just changed the sign of the imaginary part. And this is important because when we have division by a complex number, remember we multiply the numerator and denominator by the conjugate. And whenever we multiply a complex number by its conjugate, the imaginary part goes away, doesn't it? So we would distribute up top and we'd get 8 plus 8i. And we distribute down below and first terms gives us 4. Outside and inside are going to cancel, aren't they? Positive 2i and negative 2i just goes right away. And then we do the last I times I, negative I times I, is negative I squared. But what's the value of I squared? Negative 1. So it's 4 minus negative 1, which is 5. And they may write it like this, and they may split it like this. You just go with whichever way they do. Either way. Yes, ma'am.
You have 2i at the top and I at the bottom.
Oh, because I messed up.
Awkward.
Woo!
Thank you.
Good catch. Thank you, Yuri Grace. All right, now, if we were going to multiply, here I'm just expanding this binomial, this complex number, raising it to the second power. So you square the first, you double the product is 6i, we double that, we get 12i. You square the last, which is 9i squared. But what is the value?
-9.
-1, so that makes -9. So this simplifies to -5 plus 12i. This was all on the first test we took this year. So if you kept your papers from last fall, in your notebook you should have the review for this unit, and it should be corrected. But if you can't find that, guess what I'll be uploading to the website later on today? The review from this unit and the answer keys. All right, so here we have a quadratic. This quadratic does not factor, so what do we use to solve? Quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get 4 plus or minus 16 minus 32 is negative 16.
That factor.
And the square root of negative 16 is? No, it doesn't.
No, it doesn't.
4i.
2 and 2.
And then we divide everything by 2. So we get 2 plus or minus 2i. Okay, now, just to make sure we know how to add and subtract, I think this is mundane, but here we go. Here we're subtracting two complex numbers. We just distribute the negative, right? And combine real parts and combine imaginary parts. Done. Okay? All right, next section, rational exponents. So, with a rational exponent, we have x
Other kids learn this?
raised to the a over b. Huh? Everybody in 10th grade learned this year. Yep. So, the top number of the rational exponent represents the power of which you're raising the base to. The bottom, the denominator of the rational exponent, represents the root which you are taking. So, x to the a over b could be thought of as the b root of x to the a, or the b root of x raised to the a.
I remember some of this. Tell me this is on our formula sheet, though.
No, this is not on your formula sheet. Now, if they gave you a straight numeric expression, then you're punching it in your calculator. So I really don't think they're going to do that. But let's just remind ourselves what this means. This means the cubed root of 64 squared. So the cubed root of 64 is 4, and 4 squared is 16.
I got the answer.
Okay, how can I rewrite this?
Wait, how do you know if the exponent is inside the radical or outside parentheses?
We always took the root first because it made the number smaller.
Okay.
Okay, so this would become x to the 2/4, good, which is the same as x to the 1/2 power. And the 1/2 power is always the same as what root? Square root. Cubed root is what power?
3.
1/3. Square root is the 1/2 power. Cubed root is the 1/3 power. Okay, now we could have this. How would we simplify this? Because your calculator is going to give you a decimal. So I want to be able to take the 4th root of something. Okay, it's going to be a power of 2, isn't it? 2 to the 4th is 16. So we're going to break this down into 2 times 16 because the 4th root of 16 is something we know. It's 2. So I can take the 2 out and it leaves a 2 under there.
Can't you just like plug that first one in your calculator and get the decimal and then test all the other ones? See what gives you the same decimal?
You could. Yeah. Yeah. So Nora's talking test-taking strategy. She's saying, do we have to do this if it's a multiple choice? No. You can actually change this into a decimal, change all of your answer choices into a decimal, and see which one matches. That is another test-taking strategy. So if you weren't able to go from here to here, that is a great way to do it. Okay, now this one. This is actually what I think you'll see. Like the 5th root of y to the 6th. So we can think of this as the 5th root of y times y to the 5th. Isn't that the same as y to the 6th?
Yes.
Well, now we can see clearly the 5th root of y to the 5th is just y. And that leaves a 5th root of y under. Okay? Now, I will put the review up so you can see additional problems. But I want to remind you of all of our rules. And you may not need to write these down. When you multiply like bases, what do you do with their exponents? Add them. When you divide like bases, you subtract. Power to a power, you multiply. A product raised to a power, each term gets raised to that power. A product, a quotient raised to a power, both the numerator and denominator get raised to this power. So let's say we had something that was a little more interesting than some of the other examples. We had this, m to the fourth n squared to the 1/2 times the square root of m squared n squared. Okay, so this 1/2 basically gets distributed in this, right, Drew? So 4 to the 1/2. Power to a power, we're going to multiply, so that becomes m squared. Power to a power, you're going to multiply. What's half of 2? 1. Now we're taking the square root of this. Well, the square root is the same as raising it to the 1/2 power. So we're taking half of these. So this is m to the first, n to the first. So what would that simplify to?
M cubed
times
n
n
squared.
Yeah.
That's much easier to do.
Okay, so your homework for tonight is 2 units, actually. You're going to do the Unit 2 practice items. And the Unit 4 practice items. Whoops, that's not a 4. And once again, I will answer questions tomorrow, but you have the answers there with you. Okay? And tomorrow, we move on to our biggie unit on quadratics. Yes! Love quadratics.